talk about writing the inverse for a given function. Inverse means to invert something or switch two things, and what an inverse does is it switches the domain and the range for a function. So essentially, remember that the domain is the x values and the range is the y values. So the process we use to find the inverse is first we write the function using a y rather than an f of x, and then we switch our x and our y. So anywhere there was a y, we're going to write an x, and anywhere there is an x, we're going to write y. So now we have x equals 8y minus 3 instead of y equal to 8x minus 3. And then we want to change it into a function. Well, not change it, but get it so we can write it as a function of x. So we are going to now solve this equation for y. So we want to isolate y, get it all by itself. So I would add 3 to both sides, and that would give me 8y is equal to x plus 3. And then all I have left is to divide both sides by 8. And there is my inverse. Now you can go ahead and write this as 1/8 x plus 3/8, or you can leave it as x plus 3 over 8, which depends on what you prefer. We typically write the inverse as f negative 1 of x. That's our inverse of x. So our inverse of x is x plus 3 over 8. Okay, here's another example. So again, let's go through the steps for writing an inverse function. The first step is to write it using y instead of f of x. The next step, we're going to switch all x's and y's. So anywhere there's an x, we write y. Anywhere there's a y, we write an x. So we have x equals 2y minus 1 over 3 plus 7. And then we solve that equation for y to find our inverse. So order, I would subtract 7 from both sides first. So now I have x minus 7 equals 2y minus 1 over 3. Now I need to remove that fraction. So I'm going to multiply both sides by 3. And I get 3x minus 21 equals 2y minus 1. I'm still working to isolate the y. So the next thing I'm going to do, excuse me, is add 1 to both sides. And I will have 3x minus 20 equals 2y. And my very last thing to get y by itself is to divide everything by 2. Okay, and again, you can write that as 3x minus 20 over 2, or in this case, what we've done is separated into 2 parts. So we'll have 3 half x minus 10. And then we want to write that as an inverse. So instead of y, we're going to write f with a negative 1 as our exponent of x equals 3 halves x minus 10. Okay? And the only reason that I wrote the f inverse on the left instead of the right is just because that's the typical way that we see it. Okay, here's another example. I'm trying to use kind of the different things you might see on your assignment. So here is our first step, again, is to write y equals the negative square root of 2x minus 1 plus 3. Switch our x's and y's, so we'll have x equals negative square root of 2y minus 1 plus 3. Now we're going to solve that for y. So we want to get y all alone. My first step would be to subtract 3 from both sides, which gives me x minus 3 equals negative square root of 2y minus 1. I could divide by a negative if I want to, or I can just go ahead and square both sides. The reason I'm squaring it is to remove that radical. And I'll have 2y minus 1 equals x minus 3 squared. Okay. Still need to isolate the y. I have a little more work to do. I'm going to have to add 1. Notice I'm not multiplying that x minus 3 squared out. It's easier just to leave it in that form. Saves us a little work and doesn't really make a huge difference in our function. And finally, we're going to divide both sides by 2. Okay. Now this one would probably be best to write separately. x minus 3 squared divided by 2. We can also write that as 1/2. X minus 3 squared plus 1/2 equals y. So our function is going to be, for the inverse, is going to be f inverse of x equals 1/2 x minus 3 squared plus 1/2. And there we go. Okay. I have a few more examples just so I can, like I said, give you a better idea of how to do each type of problem. Again, we start by putting a y there instead of f of x, just for simplification as far as the way things look. We switch x and y, so if x equals the third root of 5y plus 4, and now we want to get y by itself. So we say, okay, what do we have to do? This is a 1/3 root, what that little 3 outside the radical means. So we want to take both sides to the reciprocal power of 1/3, which would be the third power. Okay, a square gets rid of a square root. A cube, or a third power, gets rid of a third root. So now I have x to the third equals 5y plus 4. And I can go ahead and solve for y. I have x to the third minus 4 equals 5y. And lastly, I'm going to divide both sides by 5. And again, you have the option of just leaving it in this form, or you can write it as 1/5 x to the third minus 4/5. Go ahead and divide that 5. And then we write it in function notation. The inverse of f of x is 1/5 x to the third minus 4/5. Hey, here's another. This one I put in because this one looks pretty straightforward and simple, but people tend to get stuck. So I'm going to go through the steps to kind of show you how we go about this. So we start the same way we always do. We write it as y equals. We switch our x and y values. So I have x equals 2 over y minus 3. We're supposed to solve this for y. Well, the first thing we're going to have to do is clear that denominator. So we're going to take both sides by the denominator times the denominator. Over here it cancels. That's what we wanted. And on this side I have y minus 3 times x. Now I'd have to distribute that. And now I have xy minus 3x. The reason I had to distribute and not leave it in parentheses is because I'm solving for y. So I needed the y not to be in parentheses with something else. Well, now we're, again, thinking of our goal. Our goal is to get y all by itself. So I need to move anything that doesn't have a y in it to the other side. I'm going to start by adding 3x. And I get xy equals 2 plus 3x, or 3x plus 2, whichever way you prefer to write it. And now I have x times y. I want y all alone, so I do the opposite of multiplying by x, and I divide both sides by x. And so notice I get the rational function y equals 2 plus 3x over x. You can separate that into two fractions if you would like, or you can just leave it in this form. So we have the inverse of x is equal to, or inverse of f of x is equal to 2 plus 3x over x. If you wrote that as 3x plus 2 over x, that would be correct also. Or 2 over x plus 3, that would work also. And here's our last example. Now this one's a bit more complicated because it requires us to go a little bit out of our comfort zone. But we started the same way. Notice they gave us a domain here that x is going to be greater than or equal to 3. That's because if we graph this, it would be a parabola that is at its vertex is at 3. Okay, so our y values on that have to be greater than or equal to 0. So in the inverse, our x values, or 3, excuse me, in the inverse, our x values will have to be greater than 3. And you'll see a little bit better y after we find the inverse. So again, we start the same way. We write down our function with a y, and then we put an x everywhere there is a y, and a y everywhere there is an x. So we have x equals y squared minus 6y. Now we're supposed to solve this for y. The problem is we have a y squared and we have a y, which we can't combine them, we can't really separate them. Anytime we have this, we know we have to factor in order to solve. So we need to get the function equal to 0. So what I'm going to do is subtract x over to the other side. This one's a little different than our others. I'm going to subtract x from both sides. I'm going to just write it down there on the end. So I have 0 is equal to y squared minus 6y minus x. Now we're going to treat this x down here on the end like a constant because it doesn't have a y with it. And remember, when we use the quadratic formula, since that's what we're going to use here, a was the number in front of this first squared, the y squared. B is the number in front of y, and c is this number on the end. So we're going to plug that into the quadratic formula to find our solutions. Here is the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And we just substitute our values in there. So we'll have negative of negative 6 plus or minus, because our b is negative 6, negative 6 squared minus 4 times a was 1, and c is actually negative x. We'll write that all over 2 times a, which again was 1. Then we want to try and simplify that. So we have a positive 6 plus or minus the square root of 36 plus 4x all over 2. Now this radical, if we can simplify that at all we want to, can we factor anything out of 36 and 4? Because we can't take square roots separately when there's addition in the middle. But if we can create multiplication in there, we can simplify it a little bit. Notice that 4 goes into both of those. So I can rewrite my under the radical as 4 times 9 plus x. Notice if I distribute the 4 back through there, I will still get 36 plus 4x. And it's all over 2. Well, I can go ahead and take the square root of 4. The square root of 4 is 2. So now I have 6 plus or minus 2 times the square root of 9 plus x all over 2. And I can reduce this because 2, the denominator, goes into each of these terms. And I finally get 3 plus or minus the square root of 9 plus x. Okay, now we have to keep in mind that we only wanted certain values, right? We only wanted this where x is greater than or equal to 3. So we're not going to write down both answers. We're only going to write down one of the answers. We're going to take out the negative part. We only want the positive. Okay, so here is our inverse function. That one worked way different from the rest of our examples. But here we have it. The inverse of f of x is 3 plus the square root of 9 plus x. Okay, so that should give you an example of each of the problems on the assignment. Let me know if you have questions.